Learn how to draw and understand Hess cycle routes for enthalpy calculations. A Hess cycle shows alternative routes between reactants and products, helping us calculate enthalpy changes we cannot measure directly. Let's understand what a Hess cycle is and why we use it. A Hess cycle is a diagram that shows different possible pathways for getting from reactants to products in a chemical reaction. It's based on Hess's law, which states that the total enthalpy change is independent of the route taken. The enthalpy change for the direct reaction equals the sum of enthalpy changes along any alternative route. Most Hess cycles use a triangle structure with three key components. The three corners of our triangle represent reactants at the top left, products at the top right, and elements in their standard states at the bottom. Now let's add arrows to show the different pathways and what they represent. The horizontal arrow at the top represents the direct route from reactants to products with enthalpy change delta HR. The left downward arrow shows breaking reactants down into elements, which is negative sum of formation enthalpies of reactants. The right upward arrow shows forming products from elements, which is positive sum of formation enthalpies of products. Now we can write the equation that connects these pathways. The enthalpy of reaction equals the sum of formation enthalpies of products minus the sum of formation enthalpies of reactants. We get this equation by following the arrows clockwise around the cycle, adding up all the enthalpy changes. Let's apply this to a real example, the formation of water from hydrogen and oxygen. Consider the reaction where hydrogen gas reacts with oxygen gas to form liquid water. In this cycle, the reactants are already elements, so the left arrow has enthalpy change of 0. The right arrow is the formation enthalpy we want to find. The enthalpy of reaction equals the formation enthalpy of water minus 0. Let's look at a more complex example, the combustion of methane. Methane reacts with oxygen to produce carbon dioxide and water. The cycle shows methane and oxygen at top left, products at top right, and elements at the bottom. The combustion enthalpy equals the sum of product formation enthalpies minus the formation enthalpy of methane. The direction of arrows is crucial for getting the signs correct. Going forward along an arrow uses positive delta H, while going backward uses negative delta H. When you follow an arrow in its direction, you add that enthalpy change. When you go against an arrow's direction, you subtract that enthalpy change. Let's review common mistakes students make when drawing Hess cycles. Mistake 1 is drawing arrows in the wrong direction, which flips all the signs in your calculation. Mistake 2 is forgetting to multiply enthalpy values by the stoichiometric coefficients in the balanced equation. Mistake 3 is placing reactants and products in the wrong positions on the cycle. Let's summarize how to draw and use Hess cycles. Start by drawing a triangle with reactants at top left, products at top right, and elements at the bottom. Add arrows showing the direct route and the alternative route through elements. Label each arrow with the appropriate enthalpy change, using formation or reaction enthalpies. Follow the arrows around the cycle to write the equation connecting all the enthalpy changes. This gives you the fundamental relationship that the reaction enthalpy equals sum of product formations minus sum of reactant formations.